To convert 0.00736 into express the power of 10, also known as the standard form, follow this step. The decimal 6 times to the right in the number that the resulting number m equals 7.36 is a greater than or equal to 1 but less than 10. Since we move the decimal to the right, the exponent is negative n equals negative 6. The power of 10, m times 10 power of n equals 7.36 times 10 a power of negative 6. For 0.000736 in a power of 10 is 3.6 times 10 a power of negative 6.
Good day everyone! In this video, I'll be showing to you on how to express 5.36 to the power of 10. Move the decimal 0 times to left in the number so that the resulting number is m equals 5.36 and is greater than or equal to 1 but less than 10. Since we move the decimal to the left, the exponent n is positive n equals 0. The power of 10 form is m times 10 exponent n equals 5.36 times 10 to the 0. Therefore, 5.36 is equals to 5.36 times 10 to the 0.
The next problem we are going to solve is applying scientific notation. Scientific notation states that the coefficients of the power of 10 is always expressed with one decimal place and required power of 10. Now let's move on to the problem. There are 5 digits in this problem. Since it's a whole number, so the decimal point will starts from right moving to left. So let's start to count. 1, 2, 3, 4. In order to get the power of 10, the number of how many times you move the decimal point will be the number in the exponent. Since we move the decimal point 4 times, so the exponent will be 4. It's positive 4 because according to the rule number 1, if the number is greater than 1, you will move the decimal point to the left.
Let's try our activity applying the scientific notation. So the number is 89.99. Move the decimal point to make 89.99 and new number between 1 and 10 because our number is greater than 10. We move the decimal point to the left. Drop any trailing zeros. Keep track of how many times we have moved the decimal point. So the result is 9.99 and 8.999. Define the power of 10. Okay, because our original number was greater than 10. The power of 10 is positive. Remember, we move the decimal point in 1 times. 1. So, the exponent is positive 1. The exponent is positive 1. And now the final result is 8.999 times 10. And the exponent is positive 1. Oh. And that's all. Thank you.
Good morning, everyone. My name is Lapido, and I'm here today to discuss to you the process of solving for the total resistance. There are two ways to solve the total resistance. Those are the product over sum, and the other way is the reverse method. Today, we are going to use the reverse method, so let's start. So this is the formula. We can use it in the given problem, which is a mixed problem. First, we will solve the first set, which is R1, R2, and R3. We will get first the total of R1 and R2. With the given formula, we will now place the corresponding number of ohms on each side. It will now be 1 over 7 and the other one will be 1 over 3. 1 divided by 7 is 0.142. Then 1 divided by 3 is 0.333. And some of you will be confused because if we're going to use calculators, the result will be 1.333333. Lots of 3, plenty of 3s. But we're just going to get the first 3 numbers. And let us now add them, the 0.142 plus 0.333. And it will be 0.476. Then after that, we will again divide 1 by 0.476. And the total is 2.1. Therefore, the total of R1 and R2 is 2.1. Let's now add the R3 because it's been a series of R1 and R2. 2.1 plus 2 is equals to 4.1. Therefore, the total of ohms of R1 and R2 and R3 is 4.1. Before we begin with the second set, we will first solve for the total of ohms of R5 and R6. So 4 plus 1 is equals to 5. Therefore, the total of ohms of R5 and R6 is ohms 5 or 5 ohms. Let's come now to the second set, which is the R4, R5, and R6. Just like what we did in the first set, we will put the corresponding number of ohms given in the problem. It will be 1 over 5 and the other one will be 1 over 5 also. We'll now divide it all again. So 1 divided by 5 is 0.2. And because both of them have the same numbers, then the other one should be 0.2 also. We will now add the two given, which is 0.2 plus 0.2 is equals to 0.4. Now that we added it already, we will now divide it again. 1 divided by 0.4 is equals to 2.5 ohms. Therefore, the total ohms of R4, R5, and R6 is 2.5 ohms. So just like what I've said, we are near the last part. So we will also follow the formula. We will now add the two total results of both sets. 4.1 plus 2.5 is equals to 6.6. So all in all, after we solve it step by step, the official total resistance is now 6.6 ohms. So guys, that would be all for today. I hope you learned something from my brief discussion of how to solve the total resistance of a mixed problem. Thank you so much and goodbye.